Hello friends, this presentation will explain you how the refrigerants are named. So the term used for naming the refrigerants is called as refrigerant nomenclature. So what we mean by refrigerant nomenclature is, in simple English, it means how do we name a refrigerant. So for that, we follow the ASHRAE refrigerant numbering system. ASHRAE is American Society for Heating, Refrigeration and Air Conditioning Engineers, and they have a very systemic approach to name a refrigerant, and because of that approach, by just looking at the name, one can identify the chemical composition of the refrigerant. One can get an idea about its structure as well as some idea about the properties of the refrigerant. So, what is this system of nomenclature or naming of the refrigerant? So, we'll first talk about the naming of halocarbon refrigerants. Now, what do we mean by halocarbon refrigerants? Halocarbon refrigerants means the refrigerants which are obtained from hydrocarbons by replacing one or more hydrogen atoms with a halogen. And you know that halogen means elements like chlorine and fluorine. So, in the ASHRAE scheme of things, in the ASHRAE numbering scheme or the ASHRAE naming scheme, uh, we would call it as a XYZ rule. So, a refrigerant would be named as RXYZ. Now, we need to understand what is X, what is Y, and what is Z. So, X has to do with carbon atoms, Y has to do with hydrogen atoms, and Z has to do with the fluorine atoms. And the remaining atoms would be that of chlorine. So, this we'll have to remember. RXYZ, if it is the name of the refrigerant is RXYZ, then X is has to do with the carbon atoms, Y has to do with the hydrogen atoms, and Z has to do with the fluorine atoms, and the remaining valence is that of chlorine. However, we need to do some addition and subtraction in order to achieve the carbon and hydrogen atoms. So, if for example we have a refrigerant R22, then R22 is like R022. It means that your X value is 0 because there is no number. It's just a two digit number R22. It is not R200. So R22 means then the X element is having a value of 0, Y is having a value of 2, and Z is having a value of again 2. So X, as I said, is related with carbon. So it doesn't mean that carbon is 0. It simply means that carbon is 0 plus 1. So what does X indicate? X indicates a number of carbon atoms minus 1. Right? What does X indicate? X indicates the number of carbon atoms minus 1. Right? So if X is the number of carbon atoms minus 1, if the X value is 0, the carbon atoms would be X plus 1. So 0 plus 1 would be the case when we are having R22. So in R22, the value of X is 0. So the number of carbon atoms is plus 1, more than 0 by 1. In hydrogen, we follow exactly the opposite rule. Y value is 2. If the Y value is 2, then the hydrogen is minus 1. So 2 minus 1 is 1. And Z is as it is. Z is as it is means if the Z value is 2, it means that the fluorine is 2. So XYZ formula, RXYZ formula, X would be basically talking about carbon, but that carbon is not directly obtained. It is X, whatever is X plus 1 is the number of carbon atoms. Y stands for hydrogen. Whatever is Y minus 1 is the number of hydrogen atoms, and Z is the number of fluorine atoms. Then chlorine atoms is obtained from the remaining valency. For example, let us again discuss the case of R22. So in R22, X is 0. So number of carbon atoms is 0 plus 1, that is 1. Y is 2. So number of hydrogen atoms is 2 minus 1, that is 1. And number of fluorine atoms is 2. So 1 plus 1, 2. So in carbon 1, the valency, because it is carbon is 1, it means that it is methane derivative. And if it is methane derivative, it means that the total valency has to be satisfied by 4 hydrogen atoms. And because there is only one hydrogen atoms, the remaining 3 hydrogen atoms would come from the halogens, because it is a halocarbon. So if 1 is the hydrogen atom and 2 are the number of fluorine atoms, so 1 plus 2 is 3, we have one more place, and that remaining valency goes to chlorine. So it means that R22 is 1 carbon, that is C, 1 hydrogen, that is H, 1 chlorine, that is Cl, and 2 fluorine, that is F2. So it is CHClF2. So R22 is CHClF2. So this way, just by looking at the name R22 by your RXYZ rule, we have obtained the chemical formula or the chemical composition of the refrigerant. Similarly, let's take a case of R134A. So in this case, X is 1. It means that it is having 2 carbon atoms. 2 carbon atoms means it is a ethane derivative, not a methane derivative. So if it is a ethane derivative, it means that now you will have 2 carbon are linked. So 3 and 3. So total 6 valences are to be satisfied. 2 are the number of hydrogen atoms, because 3 minus 1 is 2. Hydrogen atoms are 2. And fluorine is 4, because as it is, we have the third place is 4. So fluorine is 4. Hydrogen is 2, because 3 minus 1 is 2. And carbon is 2, because 1 plus 1, 2. So then we have 2 hydrogen, 4 fluorine, and now the chlorine remaining valence is 0. So there is no chlorine here, right? So it is C2H2 F4. There is no chlorine. So just we have got the full chemical formula of R134 by looking at the refrigerant, and A stands for an isomer. Okay, so this way we can use the RXYZ scheme, where each digit X represents the carbon plus 1, Y represents the hydrogen, and that minus 1 is the actual hydrogen, and Z is the actual fluorine. So if we remember this, we'll get to know whether it is a methane derivative or ethane derivative or propane derivative. We'll get to know how many are the number of hydrogen atoms, how many are the number of fluorine atoms, and if present, how many are the number of chlorine atoms. The other important refrigerants, which are not obviously halocarbons, they are the natural refrigerants, and they are named differently. For that, a very simple system is used. 700 series is reserved for the natural refrigerants to distinguish it from the synthetic halocarbons. So the nomenclature rule is very simple in this case. What we do is that the general rule is 700 plus the molecular weight. So in case of ammonia, ammonia being a natural refrigerant, the name would be 700 plus the molecular weight of ammonia, which is 17. So the name or the nomenclature of ammonia is R717. Similarly, carbon dioxide, you know that the molecular weight is 44. So the name of carbon dioxide is R744. Water, which is the refrigerant used in absorption systems, it is having the molecular weight of 18. So as you have guessed it right, the name of water would be R718. Another important category of refrigerants are the refrigerant blends. If it is a zeotropic blend means it is a blend of two or more refrigerants, but it does not have a single boiling point. It is having a range of boiling point, which is called as a temperature glide. Okay, so that those are known as zeotropic blends. So how to know whether it is zeotropic blend? So for that, uh, R4XX series is kept reserved. So R407 means because it is 4 and something two more numbers. So R407 means you will automatically know that it is a zeotropic blend. Whereas if it is an azeotropic blend means again a mixture of two or more refrigerants, but it is having a single boiling point. It behaves as a single component refrigerant and there is no temperature glide during the phase change. So for that we have a R5XX series. So for example, R502 is a refrigerant which is of a category azeotropic blend. You'll find often the numbers A, B, C, which are used after 407, 401, 502, and so on. So, for that, we need to understand that this A, B, C are suffix letters. They simply represent the different composition ratios of the same blend family. So, 407C would have R32, R125, and R134A. 407B would also have R32, R125, and R134A, but in different proportion. Similarly, 407C would also have R32, R125, and R134 blend, but in some other proportion. So just the composition ratio changes, and to distinguish between them, we have the suffix letters ABC. Similarly, you will also find that there is a suffix called small a. So R134 small a, okay, that is a saturated compound with no double bonds. So it basically that small a would indicate isomer. Isomer means what? Isomers are the compounds which is having the same chemical formula, but the molecular arrangement is different. This you are learning chemistry, right? But if the chemical arrangement changes, so if the structural arrangement changes, then it is important because it affects the properties of the refrigerants. That is why we need to know which isomer is being used. So R134A and R134, these two refrigerants, R134 and R134A, these are refrigerants which are having the same chemical formula. However, the molecular arrangement is different as you see in this figure, and this different structure would result in distinct thermodynamic properties. That is why we need to name them differently. So mind well that when you are using a suffix like small a, R134A, to distinguish between R134, we are highlighting that these two refrigerants, in spite of the fact that they are having the same chemical formula, have different thermodynamic properties. Okay. One more thing to wind up. Uh, there is one refrigerant which is now widely used, and it is R1234YF. In this case, you will find that there is one more digit, additional digit which is used, and that is the first digit 1. So what it indicates is, it indicates that there is a double bond in that refrigerant, and because there is a double bond, the presence of the double bond would mean that uh, it is going to have a lower global warming potential as compared to hydrofluorocarbons. So hydrofluoroolefins with double bonds, they are having a number which is not a 3-digit number like hydrofluorocarbons. It is having a 4-digit number, and the first digit would indicate the presence of the bonds. So one would mean that there is a one unsaturated bond or double bond which is used. So the importance of naming a refrigerant is now very clear, that it identifies the chemical composition, it supports the environmental compliance, It standardizes the practice because now, if you want to purchase the refrigerant from the international market, a similar name would help us choose the refrigerant better. Okay, and it would also help us in servicing and maintenance issues, ensuring safety and performance prediction. So these are the this is the importance of naming the nomenclature in a unique way by following the ASHRAE guidelines.